Hello viewers, this is Dr. Salman Zafar welcoming you to another video on the nomenclature of organic molecules. And today we are going to discuss the nomenclature of aldehydes according to IUPAC system. So let's jump on to it. Aldehydes are molecules with a carbonyl functional group that has a hydrogen atom attached to it on at least one side. So you can have an aldehyde having a hydrogen on one side and an alkyl group on the other side. This is a general structural formula for an aldehyde. But of course you can have hydrogen on both sides of this carbonyl functional group. In that case, it's a specific molecule named as formaldehyde. Now let's see how we can name them according to IUPAC system. So these are certain IUPAC rules that you have to follow while naming aldehydes. The first rule, of course, is to select the longest possible chain with the carbonyl functional group. In this case, the carbonyl functional group is an aldehydic functional group. Now, because aldehydes have a carbonyl functional group that has a hydrogen on one side and an alkyl chain on the other side. So you have to start numbering from this aldehydic carbonyl functional group. This will always be your carbon number 1 if aldehyde is the major or the parent functional group in the molecule. And to name the molecule, you have to replace the last E of the corresponding alkane by Al. So if you have a molecule like this, as I told you earlier, this is commonly known as formaldehyde, but according to IUPAC rules, this will be named as methanol. Why? Because this molecule has one carbon atom and it has an aldehydic functional group. So the corresponding alkane that has one carbon in the structure is known as methane, and we replace the last E of methane by Al, so the name methanol. If you have a 2-carbon chain with an aldehydic functional group, then the name of the corresponding alkane, of course, is ethane, and the last E of ethane is replaced by Al, so the name ethanol. Similarly, if you have a 3-carbon chain with an aldehydic functional group, the name would be propanol. And butanol, pentanol, hexanol, heptanol, octanol, and so on. Now, this carbon chain with this aldehydic functional group may have certain substituents attached to it. So if you have substituent, you have to identify the type of the substituent and the number of the substituent as well. And then you have to mention them before the parent name. And of course, you have to mention the position of the substituent as well. Remember, in every case, the aldehydic carbonyl carbon will be your carbon number 1. So numbering will always start from the aldehydic carbon. And for that reason, you don't need to mention the position of the aldehydic functional group. You just have to mention the position of the substituents in the chain. So if you have this molecule, first you have to select the longest chain with this aldehydic functional group. This is your carbon number 1. So you start from here and select the longest chain. So we can have 2 chains, 1, 2, 3, 4. This carbon chain has 4 carbons. The other chain that we can have is 1, 2, 3 carbon atom chain. So this is not the longest chain. The longest possible chain is a 4 carbon chain. And then you number the carbon atoms in the chain, and as I told you earlier, that the numbering will always start from the carbonyl carbon of the aldehyde. So this will always be your carbon number 1, and then you number all the other carbon atoms in the chain. And now you see that at position 2 we have a methyl substituent. So you have to mention the position and the name of this substituent first, followed by the parent name. So this would be 2-methyl, and because we have 4 carbon atoms in the longest chain, so the corresponding alkane is butane, and the last E of butane is replaced by Al because we have an aldehydic functional group in the molecule. If we have a multi-substituted carbon chain, now in this case we have 1, 2, 3, 4, 5 carbon chain with a hydroxyl group on one of the carbon atoms and a methyl group on the other carbon in the chain. So again, you number the carbon chains starting from the aldehydic functional group, and now you see that at position 3 we have a hydroxyl group, and at position 2 we have a methyl substituent. And you have to mention all the substituents separately in alphabetical order. So in alphabetical order, first you have to mention the hydroxyl group along with its position, and followed by the methyl group along with its position, and finally you end the name with the parent name. So this would be 3-hydroxy, 2-methyl, and because we have 5 carbons in the chain, so the corresponding alkane is pentane, and the last E is replaced by Al because of the aldehydic functional group. Now, if you have double or triple bonds in the chain, then you have to mention their position as well. Additionally, you can also have a ketone functional group in the chain along with an aldehydic functional group. So you have to remember that in the priority order for naming functional groups, aldehyde has a higher priority than a ketone functional group. So whenever you have aldehyde and ketone both present in the same molecule, the parent name is because of the aldehydic functional group, or the parent name belongs to the aldehydic functional group, or in other words, the molecule as a whole is an aldehyde. So where does ketone go? Ketone is taken as a substituent, and it is mentioned as oxo as a substituent on this aldehydic carbon chain. So let's see how we can name them according to these two rules. So first you have a molecule with this aldehydic functional group and a double bond present in the chain. So as I told you, you have to mention the positions of the double bond as well. So you number the carbon chains starting from the aldehydic carbon. So this would be 1, 2, 3, and 4. So it's a 4 carbon chain, but at position 2 we have a double bond as well. So it's not a butanol, it's a buteneol, right? Because it's not an alkane chain, it's an unsaturated chain with a double bond here. So it's a butene with this aldehydic functional group that makes it butenol. But you have to mention the position of the double bond, right? Which is at position 2. So the complete name would be 2-butene. The last E of butene is replaced by Al, or you can name it as but-2-enol. So you can use both of these names, and they both are recognized by IUPAC. Now we have another molecule. You can see an aldehydic functional group, a double bond, and a triple bond in the chain, along with a substituent. So you have to mention the substituents first, followed by the positions of the double and triple bond, and of course you have to count the number of carbon atoms in the chains. Starting from aldehyde functional group, you number all the carbon atoms in the chain. So the longest chain is 1, 2, 3, 4, 5, 6 carbon chain with a double and triple bond and a methyl substituent attached to it. So you start numbering from this carbon. The double bond is at 2, the methyl group is at 4, and the triple bond is at 5, and in all it is a 6 carbon chain. So first you have to mention the position and name of the substituent, that is 4-methyl, because the methyl group is at 1, 2, 3, and 4, and then the complete number of carbon atom is 6, so it's a hex with a double bond at position 2, so it's hex-2-ene. Remember, you don't have to write E and E here, just write En, because this double bond or alkene is not the parent functional group. Aldehyde is the parent functional group. When alkene or the double bond is not the parent functional group, when it comes in the middle of the name somewhere, then you don't write ENE, you just write EN. And the same goes for the triple bond. You don't write YNE as an alkyne, but you write YN. So at position 2 we have a double bond, and at position 5 we have a triple bond. So this would be hex 2-ene 5-ine, and because the parent functional group is an aldehyde, so you end the name with Al. Or you can write it in this way: 4-methyl 2-hexene 5-ine Al. Right? If we have a ketone functional group in the chain along with an aldehyde, as I told you earlier, ketone has a lower priority as compared to aldehyde when we talk about IUPAC nomenclature. So in this case, aldehyde would be the parent functional group, or the parent name would belong to the aldehyde functional group, and ketone will be taken as a substituent, and we mention it as oxo. So you start numbering from here: 1, 2, 3. At position 3 we have an oxo substituent. At position 4 we have a hydroxyl group, and at position 5 we have a double bond. So we have two substituents, hydroxyl and oxo. So you have to mention them in alphabetical order. So it's a 4-hydroxy, 3-oxo, and because we have 7 carbons in the chain, so hept with a double bond at 5, so hept 5-ene, and the last E of heptene is replaced by Al. So this is how you name a multifunctional aldehydic molecule. Now you can have molecules with 2 aldehyde functional groups. You cannot have a molecule that has 3 aldehydes in the chain, because a chain can have 2 ends, and at both ends you can have an aldehydic functional group. In that case, you add a prefix di before Al, so it becomes dial. And when such a case happens, then you don't have to remove the last E. So you write the complete alkane, alkene, or alkyne name. The last E is not replaced by Al, but it is mentioned and followed by dial. So let's see some examples in this according to these rules. And remember that the numbering will be decided by the position of the double or triple bonds in this case. So you have a double bond or a triple bond in the dial situation. So first you have to see from where the double or triple bond is the closest, and if there are substituents, then you see the position of the substituent. So first you have to decide the numbering through the positions of the double or triple bonds. If they are not present, then you can decide it through substituents. Or even if double or triple bonds are present and they cannot decide from where you should start numbering, then you look for the lowest position of the substituents. So we have this molecule with 2 aldehydic functional groups in the chain, and there is also a ketone functional group, which here is acting as a substituent, right? So you can number the carbon chain from any side because both ends have an aldehydic functional group. And to number or to show the position of this ketone functional group, you have to see from where it is the closest. So from that end, then you can start numbering. So if you start from here, this ketone is at 3, and if you start from here, again the ketone is at 3. So in this case you can start numbering from either end. So it's a 3-oxo for the ketone function group, and then because we have 5 carbons in the chain, so you write pentane in full form with E because it's a dial, and then you write the prefix di ending by Al. So it's 3-oxo pentane dial. Here we have another dialdehyde. So this chain does not have any substituent, but it has a double bond. So you have to see from where you start numbering to show the position, the correct position of the double bond. And for that you need to see from where this double bond is the closest. So from this end, the double bond is at carbon number 2, and from this end, the double bond is at carbon number 3. So you start numbering from here, and the double bond comes at 2. There are a total of 1, 2, 3, 4, and 5 carbons. So it's a pentene. and you have to mention the position of the double bond. So it's a pent-2-ene, and you write it in full form, ENE, ending the name with dial because of the two aldehydic functional groups. Here we have a polyfunctional molecule. You see two aldehydic functional groups, a ketone functional group, two double bonds, and a hydroxyl group attached to the chain. So as I told you earlier, when you have two aldehydes in the chain and you want to number the carbon atoms in the chain, in this case you have double bonds and substituents as well. So when you have double or triple bonds, first you see from where these double or triple bonds would be the closest. If they cannot decide, then you see the position of the substituents. So first we have to check the position of the double bonds. So from left hand side, the double bond is at 1, 2, 3, and 4. From right hand side, the double bond is at 2. So you have to start numbering from this carbon atom. This will be your carbon number 1, and you number all the carbon atoms in the chain, carrying on till the last carbon. So this chain has 9 carbon atoms with 2 double bonds at position 2 and 5, a ketone functional group, an oxo at position 7, and a hydroxy at position 4. So first you have to mention the positions and names of the substituents in alphabetical order. So it's a 4 hydroxy, 7 oxo, and because it's a diene, so you write A after the prefix non. For 9 carbons we write the prefix non, and because it's a diene, so you write A. It's a nonadiene, and it's a nona 2,5 diene because at 2 and 5 we have 2 double bonds, and you write ene in full with E and end the name with dial. So this is how you can name a polyfunctional molecule in which aldehyde is the parent functional group. If you have a molecule that has this aldehydic functional group and it is attached to a cycloalkyl ring, then we end the name with carbaldehyde, and the name of that cycloalkyl ring is mentioned first. So we have this molecule in which we have an aldehydic functional group attached to this cyclohexane ring. So the name would be cyclohexane for the ring, and end the name with carbaldehyde. If there are substituents attached to this cycloalkyl ring, you have to mention the position and name of the substituents. Now the position of this hydroxyl substituent would be with reference to the attachment of this ring to the aldehydic functional group. So if this is the attachment of the ring to the aldehydic functional group, this would be carbon number 1 of the ring, and this numbering will move on in this direction so as to give lowest possible position to the hydroxyl group. So this hydroxyl group is at position 2 from the point of attachment of the ring to the aldehydic functional group. So this would be 2-hydroxy cyclopentane, and then you end the name with carbaldehyde. So 2 is because of the position of the substituent with reference to the point of attachment of the ring to the aldehydic functional group. So 2-hydroxy cyclopentane carbaldehyde. If this aldehydic functional group is attached to a benzene ring, so then the name is benzaldehyde. So we have this aldehydic functional group attached to the benzene ring or phenyl ring. So the name of this molecule would be benzaldehyde, and this benzene ring could also be substituted. So again, just like in the previous case, you have to mention the position and names of the substituent relative to the point of attachment of the ring to the aldehyde. So now you can see that the point of attachment of this ring to the aldehyde is this carbon atom, and the hydroxyl group is at carbon number 4 with reference to this carbon. If this is 1, 2, 3, 4, the hydroxyl group is at position 4. So this is 4-hydroxy, and the complete name of this molecule is benzaldehyde. So there is an attachment, a hydroxy group is attached at position 4 of this benzaldehyde molecule. So this is how you can name different aldehydic molecules with different substituents attached, or double bonds or triple bonds or rings in the molecule. We'll discuss some more functional groups in the upcoming videos. Thank you for watching.